Hello, everybody. This recording is to talk about valuation, the valuation of properties, how the valuation formula works, the components of that formula, and also how you might be able to adjust that formula when necessary. So, the first fundamental thing we want to think about with valuation are weights. Um, the purpose of weights involves determining a property's value. And when we talk about value, at least in the context of property taxes and in the mob tax system, we're talking about assessed annual value. Assessed annual value is the price that you would pay to rent a property for 1 year, or what you would estimate to pay for a rental of a property for 1 year. Now, property features are things like wall material, if there's a permanent fence, if the property is located in the central business district, things like that. These features each affect the assessed annual value. The amount to which they affect the assessed annual value is known as the weight. We can think about weights in three categories: something that we call the surface area weight, something that we call the property feature weights, and something that we call the structure type weights. We will provide a list of every weight in your respective standard operating procedures, SOPs, and they will be linked to here. The first weight we want to look at is surface area weight. And this is an adjustment to a property's total surface area. Essentially, what it does is it reduces the value of each extra square foot that you add to a building. And the reason that we do that is if you think intuitively about how a property is valued, if you have a property that is 100 square feet, the 101st square foot is quite valuable, and then the 102nd square foot loses a little bit, and the 103rd square foot loses a little bit after that. As you take a building and you make it bigger and bigger, each extra square foot becomes a little bit less valuable than the one before it. And so that's why we have what's called the surface area weight. And what this does is this is a weight that reduces the value of each extra square foot you add on to a building. And this is based on a statistical formula that was done on each city's data when we worked with the valuers to estimate the values of the properties and set up the valuation formula. So each Kenema has a formula of 0.75, or they have a weight of 0.75. McKinney also has a weight of 0.75. Freetown has a weight of 0.5. So Freetown is slightly different than the other cities. If you look at this SOP, I mentioned Kenema a lot, but this video is for every city because all the principles are the same. There are just some differences in the weights between the different cities because of how properties are different in those cities. But if we think about this weight, the weight of Kenema and McKinney is 0.75. The weight of Freetown is 0.5. If we were to apply this formula to Freetown, it would be 0.5. If we want to apply it to McKinney and Kenema, it's 0.75. And what it is we take the area of the property, and then if you remember exponents um, from school, you take the area and you raise it to the exponent of 0.75. So if you have a property of 100 square feet, that means when you use the weighted surface area, so you take the 100 square feet and you apply the weight of 0.75, you get 31.6. So I wanted to show this on a calculator. I have 100, I hit exponentiate. Oops, sorry, hold on. I hit the wrong button. It should be 100. And then I raise it to the power of 0.75, and you get 31.62, right? So that's what we see here, 31.6. If a property has 10,000 square feet, you take 10,000, raise it to the 0.75, and you get the value 1,000. So somebody who is a keen observer will notice here is that property B, this one, is 100 times larger than property A, 1,000 versus 100. But its weighted surface area is 32 times larger. So 1,000 is 32 times larger than 31.6. And this is because the principle we talked about earlier. The weight decreases the value of the extra area in property B to prevent it from being overvalued. So this is the idea of the surface area weight. The surface area weight is this exponent here. Now we have the property feature weights. The property feature weights are how much the property's annual assessed annual value changes when the property has that feature. So we have this example. Let's say permanent fence. And Kenema permanent fence has two options: no and yes. When there's no permanent fence, it has zero impact on the property value. When there is a permanent fence, it has a 15% increase on the property value. So if you imagine a property that has an AAV of 1,000 leons with no fence, and then you imagine that the owner builds a fence around that property, then that would mean the property value would increase by 15%. If you represent that mathematically, you take the original value, which is 1,000, and then you take 15% of 1,000, which is 150. You add those together and you get 1,150. So that would be how much the AAV increases from having the fence. Think about another example. We have wall material, which has three options: masonry, mud-based, and zinc, metal, and wood. So masonry is 0. Mud-based reduces the value by 17%, so it has a weight of negative 17. And the zinc and metal and wood, this is like palm body. This reduces the value by 30%, so it has a weight of negative 30. Now let's imagine a property that has cement walls and has a value of 1,000. Now, if magically those walls were changed to become made out of wattle, which is mud-based, then the value of the property would decrease by 17%, negative 17. Mathematically, this is represented as 1,000 plus 1,000 times negative 17. And so if we take 1,000 times negative 17, we get negative 170, negative 17%. So negative 170, you add these together. So 1,000 plus negative 170 gives you 830. So the value of that building changes from 1,000 to 830. Similarly, if the walls are changed from cement to zinc, you go from 1,000 and then you adjust by 30% of 1,000. So 1,000 times negative 30%, that gives you negative 300. So you do 1,000 minus 300 equals 70. So if you change the value of the building from having cement or masonry walls to wood walls or zinc walls, then you go from 1,000 to 700 leons. So this is the property feature weights. It's all of those different features. In Kenema, we're used to a pretty big list of features. The wall material, the wall finish, the wall state of repair, the window type, and these are similar. Each council is slightly different, but has a generally similar set of features. And then we have the structure type weight. The structure type weight works very similar to how the property feature weights work. So the model that's used to estimate the assessed annual value assumes that a property is a dwelling style structure. But what happens if the property is not a dwelling style structure? Let's say it's a filling station, or it's a bank, or it's an office building. Then we need a special structure type weight that adjusts to the type of structure that it is. So for example, a dwelling has a weight of 0 because that's a property is assumed to be a dwelling, basically. And a property that is a hotel has a weight of 70%, so the value goes up by 70%. A value that is, or a property that is a bank structure type has a weight of 106%. So let's imagine and then there's a whole bunch of, if you want to look at all the different, for example, here we have the list of House and dwelling style is 0, bank is 106, bar restaurant is 25, cool room is -18, filling station in Kenema. This is a special, not every city has the same value. Kenema has very high values for filling stations. Guest house is 25, hall is 22. So these are just how much each structure type is adjusted and the weights for them. So let's do an example. Let's imagine a property that is a dwelling style structure that has an assessed annual value of 1,000. Now, imagine you take the same property that is the same size. Imagine you create a new property. It's the same size as this 1,000 as this dwelling. It has all the same features. So, it has it's built with the same materials. The windows are the same. The roof is the same. Everything is the same, but it's designed to be a bank. So that the building is not designed to be a house. The building is specifically designed by an architect to be a bank. Well, then it has a different structure type weight. So the value would be, it would actually this says 70. So 70 would be for a hotel. So let's say not bank but hotel. If it's a hotel, then it has a weight of 70. So it's 1,000, the original assessed annual value, but then it has an additional adjustment from the structure type weight. So 1,000 times 70% is 700. So you take 1,000, you add 700, and you get 1,700. And this would be the value if the structure type was hotel instead of being dwelling or domestic, dwelling style, a house. Now, if it's a bank has a weight of 106. So you would take the original assessed annual value, and then you would add an adjustment to it based on the weight of 106. So it's 1,000 times 106%. 1,000 times 106% is 1,060. So you take 1,000, add 1,060, and you get a value of 2,060. So that's the adjustment from dwelling to bank. So, excuse me. One thing to clarify is that a structure type is meant to reflect how a structure is built. It's not meant to reflect how a structure is used. So for a property that was built as a dwelling but becomes used as an office, it's better to continue calling it a house or dwelling style, since that's how the structure was designed. The theory behind the structure type weight is that specific structure types cost different amounts of money to build on a square foot basis. So a bank has extra security features that increase its per square foot costs compared to a dwelling. A hotel, similarly, has extra plumbing, has extra electrical features compared to a normal dwelling. So these different structure types are specifically designed, by an architect, by a construction team, to have a specific design that either increases or decreases the weight of the structure compared to how a normal dwelling would be built. That is the idea. So it's not about how the building is being used right now. It's not about who is occupying the building right now. If it's a very profitable legal firm, that doesn't change the structure type, right? It's not about who is in the structure. It's about how the structure is designed. Was the structure designed to be a dwelling? Was it designed to be a bank? Was it designed to be a hotel, right? That's what changes the structure type weight. When you're answering the property type question, you should ask, how is this property designed when it was built? If it was not designed to be a dwelling, then you ask, how much more or less valuable was this property compared to the dwelling of the same size? Now, the system, this section here in the guidance notes, I won't go into it in very high detail, but it explains how the existing weights are largely based on something called Marshall units. Marshall units come from a large manual. You can read it here if you click on the link. And basically what it is it's a ratio. We use the Marshall units, which give us how much the cost is per square foot for different types of buildings. So this explains, the cost per square foot for a single family residence in Marshall units is 82.5. The cost for a mixed retail center with office units, which we call mixed retail office, that's 93. So a mixed retail office building has a higher Marshall unit cost than a single family residence. And so we use the ratio like 93, which we get here, over 82.5, which we get here. And that gives us the Marshall unit ratio, which allows us to get what the weight is that we put into mob tax. I won't go into all of this. If this is interesting to you, I encourage you to read it in the SOP. It also gives an example of, for example, cold storage facilities have a Marshall unit cost of 68. So we take 68, put it over 82.5, which is what single family residences use as their weight. And that gives us a value of 82, which is the equivalent of negative 18. I'm moving intentionally fast through here because this is kind of extra knowledge. I don't consider it essential knowledge, but if you want to understand it, I think you can understand it by reviewing the SOP. So up until this point, we've talked about the surface area weight, we've talked about the property feature weights, and we've talked about the structure type weights. The last thing to talk about is the base value. The base value is the final component of the assessed annual value formula. Every property in your database should have the same base value. Each city has a slightly different base value, but the theory behind the base value is consistent. And a very important part of that theory is that the base value for any property should be the same, whether it's domestic, whether it's commercial, whether it's government, they all share the same base value within a city. And the definition of a base value is, it's a little bit of a tricky definition, a little bit tricky to understand, but it's the value per square foot of the property if the surface area weight was 1 and all the features and structure types were 0. So that means, if we remember earlier, the surface area weight is the exponent that you use for the surface area of the building. If we change this from 0.75 to 1 or 0.5 to 1, and then we set all of the weights for the property features to 0, and we set all of the weights for the structure type to 0, then the base value would be the value per square foot of your building. This I know that's a little bit of a tricky thing to conceptualize, but it's what it is in the mathematical formula. Another way to think about it is the value per square foot of the first square foot of your property that you build, if you set all of the weights to 0. And in that case, you could use the surface area weight of anything. But let's stick with this definition for now. If we were to change the surface area weight to 1 and we set all the feature and structure weights to 0, then it's the value per square foot of your property. So let's imagine a property that has 100 square feet. Let's also set the surface area weight to 1 and set all of the feature and structure weights to 0. If the base value is 15, then what we do is we take 15, we multiply it by 100, the number of square feet, and we get 1,500. All right. Now, it's important not to think of the base value as the actual value per square feet, and that's because of the surface area weight. So when we use any surface area weight other than 1, each additional square foot value goes down because, like we said before, the surface area weight makes each extra square foot you add to a property slightly less than the square foot you had before it. And so anytime you have extra, when you go from a property of 100 square feet to a property of 101 square feet, that extra square foot is a little bit less valuable. And then if you change the property area to 102, that additional square foot is a little bit less valuable than the one before it. So we can't say that the base value is necessarily the value per square foot, and that's because the surface area weight reduces the value of each square foot. But if we change the surface area weight to 1 instead of 0.75 or instead of 0.5, if we changed it, then basically the base value becomes the value per square foot. But because it is not one, because the surface area weight is not one, then we can't really say it's the value per square foot aside from just the first square foot. I know this is a little bit of a difficult thing to understand, but hopefully, if you read the SOP and think about it a little bit, it will make sense. This video is not meant to be entirely comprehensive. It's meant to be a supplement to the SOP. So if you want to understand all the precise details of these equations, I suggest going through and reading the SOP. The only time you should change the base value is to adjust for inflation. Other than that, you should never change the base value because it is based on a calculation. It's based on a formula that was very precisely set. And if you were to change the base value, it would ruin that formula. So you should not change the base value other than inflation. And we'll talk about that later. Now, finding the base value in the weights and mob tax, the things that we've talked about. So I'm going to use the McKinney City Council building as our example. And that is property number 27091 in McKinney. So here's the McKinney City Council building. Here we, oops, let's see, I'm on staging and I think it's not working. Give me a second. Okay, now I've logged into McKinney's production server. So I can now look at the actual, okay, here's the McKinney City Council building. We have the outline of the property on the map. Okay, this is what we want to look at. So we want to see the things that we've talked about so far, the different weights and the different components of the assessed annual value formula. Let's understand where they are in mob tax. So we're looking at the features tab. And the first thing to highlight, well, if we look at our, we talked about the assessed annual value. Here it is for the property right here, the assessed annual value. Now, where are the components that we've talked about so far that go into this? Well, first is the weighted surface area, and that is located here. And we see that is located here. It's 1,340. Then we also had the feature weights. Those are located here. So for each of the different features of the property, the street status is high. That gives it a weight of 10. It has Sawako axis. That gives it a weight of 4. It has a covered well. That gives it a weight of 3. Right? We have the structure type weight. There we see it's structure type classified as municipal offices. That gives it an additional structure type weight of 37%. So 37% more valuable than a property designed to be a dwelling. And then lastly, we have the base value, which in this case is 11.74. This is the same base value for any property in McKinney. And every property in McKinney will have the same base value, 11.74. Okay, now a few things to highlight is if you are, for example, in Kenema. Kenema has properties that have specific weights that are only for commercial buildings or only for institutional buildings. So if we, for example, Kenema has parking spaces on property, but parking spaces are only measured for properties that are domestic or non-domestic. So if they are commercial or they are NGO or they are institutional, then they measure the number of parking spaces. And because this weight does not apply to all properties because it only applies to non domestic properties, then this weight is displayed in the property type area and not in the features area alongside the structure type weight. The other place to notice weights are in the measure tab. So for example, in McKinney, if we go to the measure tab, if you see this little icon, that implies that it is a layer with a calculation. And calculation layers affect the value of a property. So because the McKinney City Council is in the central business district, it has an extra value of 15%. And this is coming directly from the central business district layer in your map. So if I turn that layer on, I see here's the central business district of McKinney. I can see that in this layer. If I zoom in, I see that the city council building is inside of that layer, and so it gets an extra 15%. The other layer that affects property values in McKinney is the low community layer. These are low value communities. If I turn that on and I zoom out, I can see these are the low value communities of the city. The city council building is not in any of those, so it has no effect from the low community layer. All right. So there's three places to see the weights for your properties. The one place is in the features list. The other place is in the property type, which includes both the structure type and if there's any special weights that only apply to some structure types or some property types, then those are also listed in the property type area. And if you have any GIS based or location based variables, any any values that or any weights that come from location based values, location based weights, that is weights that come from GIS layers. Those are seen on the measure tab instead of the features tab. So now that we know where everything is located in MobTax, how do we, let's actually think about how these all fit together in the valuation formula. And we'll try to go through it actually calculating an example. So the formula has base value, which is our starting block. Then we multiply that by the weighted surface area. Then we multiply that by the property feature weights. And then we multiply that by the structure type weights. And let's see what this actually looks like if we try to do this ourselves. Everything we need is on either the features tab or the measures tab to do this. The first thing we need is the base value. That's quite easy. We simply go to the features tab. We're going to use the McKinney City Council building as our example. McKinney City Council building has a base value of 11.7412. This base value should be the same for any building in McKinney. So we have 11.7412, and we're going to use an Excel sheet. I'm using online Excel, and the reason I'm doing that is because anyone can use online Excel for free, even if you don't have a Microsoft Office license or you have an old license. If you just go to Google and search for Microsoft Excel online, you can use it for free, and I'm demonstrating that now. So here we have a base value, which is 11.7412. I took that from here. And then the next thing we need is our weighted surface area. So, if we look at our formula, after base value, we need the weighted surface area. If I look at MobTax, I see the weighted surface area value here, 1,340.3045. This is different for every building. This one is unique. Each building will have a different weighted surface area depending on the area of the building. If we want to understand how to calculate the weighted surface area, we can do that. We don't have to, but we can. The first thing we need, the first component of it is the actual roof outline area. So this is, if we calculate how much area is within this roof outline, which is the outline of the rooftop, we see that that is 9851. We also see that here, 9851. And we can calculate the weighted surface area ourselves with that. So we take the roof outline area, which is 9851, and then we need to multiply that by the number of floors. So we see in McKinney, there's 1.5 floors for the McKinney City Council building. Floors, 1.5. And if we multiply this times this, we get 14,777. That is correct. 14,777 total area. Now, we know we have to now apply the weight. To get the weighted surface area, we have to take the surface area and apply the weight to it. If you remember, the weight in McKinney is 0.75. So we take the surface area and we raise that to the power of 0.75, and we get a weighted surface area of 1,340.3. And if we look in MobTax, it's 1,340.3045. So there's a little bit of rounding going on here, but we see that this matches this. So this is how we calculated it manually and confirmed that the numbers are correct. Okay, so we've got our, at this point, we have the base value and we have the weighted surface area. Now we have to get the property feature weights. One thing to understand about the property feature weights is in MobTax, they are expressed as percentage weights. So in MobTax, you would see that street status high has a weight of 10%, having Sawako access has a weight of 4%, etc. But what we need to do for our calculation is we have to convert the percentage weights to what we call decimal proportions. And decimal proportions, I provide this formula here. And this is the way to calculate a percentage weight to a decimal proportion. First, you take the percentage weight, you divide it by 100, and you add 1. So for street status high, it has a percentage weight of 10%. So you take 10, divide by 100, you get 0.1, and you add 1, and that gives you 1.1. For difficult access, it has a negative weight. So you take negative 13, you divide by 100, you get negative 0.13, and you add 1, and you get 87. And the intuition behind this is, let's say you have a property with a original value of 100. And you have 100, and let's say you change the street status to high for that property. So that property has to increase in value by 10%, right? The weight of the high value street is 10%. So what you need to do is we need to figure out how much do we multiply 100. We have to multiply 100 by some amount to increase its value by 10%. And what we use is the decimal proportion weight. So if we use the decimal proportion, we're going to say it's 1.1 because that's what we calculated that here. We got the decimal proportion of 1.1. So if we multiply the original value times the decimal proportion rate, we get 110. And that is 110 is the equivalent of the original value with an additional 10%. So if we take the original value and we increase the original value by 10%, we get the updated value, which is 110. And the way we do that mathematically is take the original value, multiply it by the decimal proportion, and we get the updated value. Similarly, let's say the original value is 100. Let's say we change it to have difficult access yes, which is worth negative 13%. So negative 13% is the increment, this should say increase in value. Let's call it change in value because it can also decrease. The change in value is negative 13%. That means if we represent that as a decimal proportion, it would be 0.87. Okay. So converting negative 13% to a decimal proportion gives us 0.87. If we multiply the original value by the decimal proportion, we get 87. So 100 reduced by 13% is 87. Okay. Um, and so we can even multiply these together. So let's pretend the property has both a high street status and difficult access. So first we have an original value of 100, and if we took 100 and we increased it by 10% and then decreased it by 13%, so we apply both of these together, the way to do that is to multiply the one decimal proportion by the other decimal proportion. So when we combine the decimal proportions, we get 0.957. And if we multiply the original value times the decimal proportion, the updated value is 95.7 for that property. Okay. And so this is, if we apply this to the McKinney City Council building, we see these are the different weights that are affecting the McKinney City Council building. So if we look at, McKinney City Council, it has a high street status. It has easy street access. It has yes to Sawako. It has a private covered well. So what I did is I took all of these features and any of them that was not zero. So anything that's not zero, anything that's 28.85, anything that's not zero, I put it here. Okay. And so here we see that street status high is 10%. We see that Sawako access is 4%. The private well is 3%. These are all the weights that affect the property value of the McKinney City Council building. If I take these percentage weights and I change them from percentages to decimal proportions, the way I did it in this example up here, these are the decimal proportions of each of those individual weights. Okay? And if we take this and the way to get the combined feature weights is we take that and we multiply all of those together, right? So I have all of those, and if I do product of all of these, I get 8.956. And that's what we see here, 8.956 from multiplying all of these together. Okay, so at this point, we're done pretty well. At this point, we have the base value, the weighted surface area, and the property feature weights combined together. The last component we need is the structure type weight. So in McKinney, the McKinney City Council building it has the property type municipal office, which gives it a increase in value of 37% because an office building has a higher per square foot value than a dwelling. Okay, so if we take that 37% and we convert it from a percentage weight to a property type decimal proportion, so we take 37, we divide it by 100, we get 0.37, we add 1, we get 1.37. That's our decimal proportion. Okay, so this is what we need for doing the calculation. Now, what we at this point we have the combined weights from the features, and we have the weight from the property type. MobTax doesn't give you these separately. What MobTax does is it combines them together, and I'll show you how to get there. So the way we do that is we take the combined feature weights, 8.956, which is this here, okay, and we have the property type decimal proportion weight, which is 1.37. We have both of those here. We multiply both of those together, and we get 12.2697. Okay, so this is the weight. When we combine the feature weights and the property type weights together, we get 12.2697. Now, let's let's think about how to convert that back from a decimal proportion to a percent weight. So if we want to represent this as a percent, we use the formula that we had earlier. We just rearrange this formula here. We just rearrange it so that the percent weight goes on the left, and so we solve for it. And what that looks like is you take to get the total adjustment percentage, you take the proportion, you subtract 1, and you multiply by 100. So here's our proportion, 12.2697. We subtract 1, we get 11.2697. We multiply by 100, and we get, when we multiply this by 100, we get 1,126.97. All right, what happened? Let's compare that to what we see in mob tax. There it is. The total adjustments, 1,126.97, right? So this total adjustments field that we see in mob tax, this is from multiplying all the feature weights times the property type weight. But to do that multiplication, you have to convert them from percentages to decimal proportions, and then you convert them back to percentages, and you would get this total adjustments amount. So what this is saying is it's saying this total adjustments is the total adjustments is the property weights features times the structure type weights. So it's combining these together and telling you how much the different property feature weights and structure type weights affect the property value. In the case of McKinney City Council, it increases the value by 1,000% because there's a lot of things that are increasing the value of the property, right? So we have at this point we have the so at this point we've figured out all of the components we need. We have the base value, which is 11.74. We have the weighted surface area, which is 1,340. We have the combined feature weights, which is 8.956, and we have the structure type weight, which is 1.37, right? So if we multiply all of those numbers together, we get 193.085, or 193.085.9235. And if we look in mob tax and try to confirm this, we see 193.085.215. So there's just a small difference of about less than 1 leon. And this is just from rounding issues, decimal rounding issues. So we've successfully calculated the assessed annual value. We use the base value. It's a little bit difficult on my screen because it's not so large, but we use the base value, 11.74, which is here. We got the weighted surface area, 1,340, which is here. We further adjusted these by the total adjustments. In our equation, we used decimal, for our equation, we had to convert those to decimal proportions. So we had the decimal proportion of the weights from the features and the decimal proportion of the weights from the structure type. And we multiply those both together, and we get the percentage, we get the total adjustment. And if we were to represent those total adjustments, the total adjustment as a decimal proportion is 12.2697. If we were to represent that as a percentage, we get this 1,126%. Okay, so that's 1,126.97%. Obviously, you can see here that matches what we see in mob tax. And so that means that we have successfully put together all of the components that we need. We know how to find them in mob tax. We know where to find the base value. We know how to find the weighted surface area. If you want to understand the other components here, The surface area value is just multiplying the weighted surface area times the base value. So we get, if we multiply this number by this number, we get this number. Then if we take this number and adjust it by this percentage, 1,126.97%, then we get the assessed annual value, and that's what we calculated. Hopefully this makes sense. Let me do one last thing to show you how this, I want to keep continuously demonstrate how you adjust from the percentage back to the decimal proportion. So if you remember our formula for the decimal proportion, or if you reference it in the standard operating procedure, it is here. So you take the weight, you divide by 100, and you add 1. So if we have a these at this point, we have our weighted surface area, we have our base value. If we have our adjustments as a percentage, that is this number here, 1,126.97. Now, if I simply, like I said before, the formula for this, it's divide by 100 and then add 1. So if I take this and I divide it by 100, let's put it in parentheses just to make sure we do everything in the proper order. And then I add 1, I get the weight of 12.2697. If we reference back to this, we'll remember that that's what we saw here when we worked that out. So everything stays consistent. And so I take the base value, multiply it by the weighted surface area, multiply it by the weight of the property type and the features, and I get this value here, 193,000. That's just